let's get started. All right, so we're going to be doing solving rational equations and radical equations. So a rational equation looks like rational is just a number, an equation, or a polynomial or a polynomial. So these are rationals, these are rational equations, these are rationals. And so our just-in-time notes that we did in our previous class was just to get you ready to do everything here. Now, honestly, I'm going to teach you a trick that you don't do too much of the stuff, but just in case you need them, okay? So these are all rational equations. The second part of what we're going to be doing is called radical equations. These are equations involving square roots or cubic roots, and I'll teach you how to solve a whole bunch of these. But the thing that you really need to pay a big attention to is you need to check all your solutions. And this is not an optional sense, since what we do to solve these can produce answers which are not in the domain or answers which are untrue. So in rational, it's usually the non-domain, so we kind of check them. And for radicals, when we get to there, I'll show you why that breaks, okay? So let's go ahead. Oops, see, I'm already writing on the wrong layer. So let's go ahead and get started. So let's pretend we have this equation. We have this equation here, and I want to solve it. And so in order to solve these, we're going to multiply both sides by the least common denominator to declare fractions. And so I've done this once with you before. I think I did this in the inequality one. But now the least common denominator will only be a number. In this case, it'll be, it'll be actual polynomials. And so here, the least common denominator between 3 and 2 is 6, right? Because 3 times 2 is equal to 6, and so this is my least common, and this is my least common denominator. And so what I'm going to do is multiply both sides by 6. So I'm going to take 6, I'm going to multiply it by x minus 8 over 3. Oops. Like that. Hi. I cannot seem to write today. And then, oops, not comma, plus x minus 3 over 2. 6 times 0. I guess let me put it in parentheses. That way it's the same. So we're multiplying both sides by 6. What does this do? Well, this clears out the fraction. So 6 times the 3 leaves me a 2 times x minus 8 plus 6 times the 2 leaves me a 3 times the x minus 3. 0 times 6 is still just 0. Then here I just get 2x minus 16 plus 3x minus 15. No, nope. 3 times this gives me 9 equal to 0. So the 2 and the 3x add up. So let's go ahead and go up here just so I have some more room. So the 2 and the 3x add up to be 5x. And then this equals minus 16 plus minus 9 is minus 25 equal to 0. 5x equals the 25, or x equals 5. Okay, so now we have x equals 5. So what do? We just plug it in here. And so here I'll have 5 minus 8, which should give me, and we'll just check it real quick. So I'm going to check it. So it'll be 5 minus 8 over 3 plus 5 minus 3 over 2. Well, 5 minus 8 over 3 is negative 3 over 3, so this is minus 1. This is 2 over 2, so this is plus 1. That indeed equals 0, so we're good to go. Okay. So this works out. So that's what we do. So the next one we're going to do here. Here we have our least common denominator. So our least common denominator here would be 3x plus 2 times 2x. And that's just what it is. It's just both the denominators multiplied to get together. Yeah, my friend who came late, just mention it and I'll mark you at the end of class. Okay, and so here we have 3x plus 2, 3x minus 2. So that's when least common denominator. We're going to multiply it by both sides. So here we're going to have 3x plus 2 times 2x. So all times 5 over 3x plus 2. Oops, don't need those marks. equal to 3 over 2x times 3x plus 2 times 2x. Okay, so once again, we just find the least common denominator. For here, there's nothing in common between these two. And so we just multiply by all the denominators, right? So here, this cancels this. The 2x cancels the 2x, so I have 2x times 5 is equal to 3 times 3x plus 2. This just becomes 10x. This becomes 9x plus 6, plus 6. And so if I move the 9x over, I get x is equal to 6. And we just check that real quick. So we have 5. So we're going to check it. So we have 5 over 3 times 6 plus 2 is equal to 3 over 2 times 6. All right, so we get 5. 3 times 6 gives us 18, so 5 over 20, which is 3 over 12. And notice here, this is a fourth, and this is a fourth, right? This is 1/4 equals 1/4 once I simplify the fraction, so it works out. So again, all we're doing here is we're going to multiply by the least common denominator. In this case, it was a number. In this case, it was a bunch of things. And then we're just left, after that, we just hit a normal equation. Here we're just left with a normal equation to solve, right? Once again, here we're left with a normal equation to solve. And so the only trick, not trick, but the new tools to put in your tool bag for solving math is that if you see a rational, you just clear out the fraction. All right, so let's look at this one. This one's a little bit more interesting. And so let's find the least common denominator here. So the least common denominator here. So here I have an x, so I'm going to need that. I'll have x plus 3 here, right? But notice if I factor this is a difference of squares. So just a little side note that x squared minus 9 is equal to x plus 3, x minus 3, right? That's what it means to be a difference of squares. It can be, I know we've seen this a couple times by now. So if you have something squared minus something squared, it's equal to something plus something, something minus the other something, right? So if I have a squared minus b squared, here's the general formula. Be a plus b, a minus b. So whatever that is. And so notice this is x plus 3 and x minus 3. And so I have an x plus 3. The only thing I need to add here is x minus 3 because x plus 3 is already included, right? Is already included here. And so the only thing I need to add is the x minus 3. And so kind of what you want to do is factor each of these. And so if it's not like a single, like this is pretty simplified, this is pretty simplified, but you can factor this. So factor that and see if you don't have to multiply by everything. It just makes your life easier. So here we're going to multiply both sides by that. So we're going to have x plus 3, x minus 3, right? Multiplied by 6 over x plus 3 plus 2 over x is equal to 5x minus 3 over, hold on, x minus 3, x plus 3. And then we're going to multiply that by x minus 3, plus 3, and x. Okay, so notice here we factored this. Okay, now we're just going to go ahead. So when I multiply this by this, these two terms cancel each other. So I'm just left with x minus 3, or x minus 3 times 6. Plus, here I have an x, so this cancels. So I'm left with 2 times x minus 3, x plus 3. Here, this factor cancels this one, this factor cancels this one, so I'm just left with x times 5x minus 3. Okay. So once we have it here, we can simplify. And so here, if I simplify this, I get x squared times 6, so it'll be 6x squared minus 18x. So that's what this simplifies to. If I simplify this, I'm just going to get 2 times this, so it'll be 2x squared minus 18, right? Because it's just, remember, this is the same as x squared minus 9, so just multiply by a 2, and a 2 is equal to, and here if I multiply the x in here, I get 5x squared minus 3x. And so once again, after multiplying by the least common denominator, we get to something which is just like an equation. And this is a normal quadratic equation, and hopefully by now you're a little more comfortable in solving it, but we'll go ahead and solve this out. So what we want to do is get everything to one side. So I'm going to, so here I have, so I have 6x plus 2x and then minus a 5x will give us, so this will be 8x on this side, minus the 5x gives us 3x squared. Okay. The plus 18x and minus a 3x. If I add 3x to this side, it'll be minus 15x. So 18x plus 3x gives me 15x. And then minus 18 right here can just stay right where it's at, equal to 0. And then we go ahead and factor this the best we can. So notice there's a 3 everywhere here, so I can factor out the 3, right? So it'll be 3x squared minus 5x minus 6 equal to 0. And notice, since if I have a 0 on this side, I can multiply both sides by a third and get rid of the 3, because a 0 times a third is still 0. So I'm just to flip this, I factor this, I get x plus 1, and then x minus 6 is how this factors, equal to 0. And that gives me my answers of x minus 1, x equal to 6. And then we check it. Just because I completely didn't leave myself enough room, I'll give you a clue. It checks out. Okay, it does check out. Let's just do the -1 in our heads real quick, because that's not too terrible to do. So here I'll have 6 over -1 plus 2. So this ends up being 6 over 2, which just leaves me 3. Here I'll have 2 over -1. So this would be 3 minus 2. It leaves me as 1 on this side. Here I'll have -1 minus 9. And then I'll have minus 5 minus 8. So this would be 1 over 1. So this leaves me 1 on this side, 1 on this side. So it checks out. You can do the same thing with 6 in a calculator. You'll find it works as well. Okay. All right. So I'm going to work through the next ones, but I'm going to have you guys kind of help me with some of the steps now. So we've seen 3 of them. We're going to do 3 more. I'm going to have you kind of help me on some of the steps in chat. So here, what's the least common denominator? Yes, so that's the least common denominator. We have a question back on the other one real quick. Oh, so here in the first part, so when I was canceling stuff, it'd be x. So this term has to see all of this, right? So let me be very clear about this. This term alone sees each one of these, right? Sees this, this, and this. And so I get rid of the x plus 3. And so I'm left with x minus 3, 6. Then undo. And since this is a plus, this term here sees all of this. And so it sees the x plus 3, the x minus 3. So it'll be 2, this, and this. So if you have terms which are separated by a plus sign, both fractions get multiplied by everything. Okay, hopefully that explains why. Good question, really good question. All right, so here you guys have written that'll be x minus 1, x minus 3. Okay. right, so that's our least common denominator. So go ahead and give this one a try. Notice how I downgraded the difficulty again for a second because I wanted you to try this one. So give this one a try and see what answers you get. So give that one a try for a second. Please do try at least this one, number 4. I'll do the rest, but I want you to at least try one. Super proud of my dogs right now. They're being mostly quiet. Better knock on wood, because now there won't be. So I'm going to go ahead and write out the next step. So here, we'll have x plus 1, or x minus 1, sorry. Okay. So there's your next step. Notice here you can cancel some things. I'll go ahead and cancel some things with you. And so you're left with 2x times x minus 3 is 5. All right, and let me know when you guys get answers and put them in chat. Something thinks I should be playing Jeopardy music during this time. It'd be hilariously annoying. It doesn't seem. Okay, so we got to a stop point. Fair enough. So I'm at this point, but I'm not sure what to do next. So let's get to that point. Let me get to the point where you guys. So we're going to multiply across. We get 2x squared minus 6x equals 5. X minus 5. All right, and so if I move this over, you get 2x squared minus 11x plus 5 equal to 0. All right, so I want to factor this, right? I assume this needs to be factored. So I'm just rewriting this up here. We'll skip the checking step for this time just because I'm going to spend a lot of time factoring it. I'll show that it works out. So here we go. So we have this. So I know I want to factor. If it factors cleanly, which you assume it does because these are textbooks problems or I gave it to you, so they're highly contrived, right? If it factors cleanly, it's going to factor in 2x and x, right? I want to find multiples of 5. So my multiples of 5 are, it's either -1 and -5, or that's it, right? That's the only choices, right? Because notice here, this is negative, right? So I don't want the positive version, right? Okay, yeah, for those who came late, just remind me at the end of class. So this is the only, so to get -5, if this factors cleanly, my only options are -1 and 5. Right, because it can't be +1, +5, because that's not going to give me -11, right? And so I'm thinking to myself, well, I need to get to a -11, and so if I put the -5 by here, I only get one of it. But I put the -5 here, I get 2 of them, right? So that gets me to a -10, and then I put the -1 here, that gets me to a -11, right? And so what you do when you see something like this, if this is not a clean factor, but it is like a prime number, just put it on one of the x's, right? So go back to this point. Oops, I'm on the wrong layer. There we go. So get back to this point. So say put 2x and an x. find your factors for your C. And so my two factors here are +1 and +5 and -1 and -5. Since this is negative, it makes no sense to check any of these. So we just cross those out. I put -5 here and I put -1 here, I'm getting -7. If I put the -5 here and I put the -1 here, I get -11. Notice here, I know I need to reach 11. And so -5 times the 2x gets me to 10, which is most of the way there. Okay, so that's how you do that. It's kind of guess and check. If you do the big X method, it's still guess and check, right? So we get to here to 0. Once we have here, I get x is equal, notice this is a half. Remember, this is equal to a half, and let me not skip that step either, I guess. So either this is 0 or this is 0, right? That's what it means, the zero multiplication rule. Either that was 0 or that was 0. If this is not 0, do not do this, right? But this, it is 0. So x, I move over the 1, divide by 2, I get x equal to a half. Here I move over the 5, I get x equal to 5. Here, if we check the half real quick, 2 times a half gives me 2 times a half gives me a half, right? Or it gives me 1 up top. A half minus 1 gives me -1, or minus a half. And so here I get -1. Here I have 5. Here I'll have, if I have a half here, I'll get -2.5. 5 over -2.5 is, hold on, if I get a 1 up top and a half down below, I get -2. And then here, if I have a 5 divided by -2.5, that also gives a 2. So yeah, this one works. I think the 5 checks better. I have 10 over 4, and this gives me 5 over 2, right? So this one also checks. Okay, so we just check those in our head. Yeah. So, all right, so let's do one where things get just as fun and interesting. So I'll just do the next two with you. I want you to see lots of these in practice. So here, once again, notice I have a difference of squares. And so my least common denominator here will be, notice here I can pull out a 5. So I can have 5x plus 1, right? So here's 5x plus 1, right? This is, if I factor this, I can get x plus 1, x minus 1. So I need an x minus 1. And here I have an x minus 1. So I have everything here with the 5, the x plus 1, the x minus 1. Because notice here, just briefly, I can write this as 5 of x plus 1. Here I can write this as x plus 1, x minus 1, because it's a difference of squares. And here this is just x plus x minus 1. And so from all of these, I just collect everything I need. I need a 5. I need an x plus 1. Here, I need an x minus 1. And notice here, I already have the x plus 1 and the x minus 1, so I'm good. Okay, so the least common denominator, just split this into all its factors and make sure you have all the factors in your least common denominator. Hopefully that makes sense. We'll do it again here. So you'll get more practice there. But since we need room to do the problem, I'm going to go ahead and erase that. All right, so now I have my least common factor. So I'm going to write 5 times x plus 1, x minus 1 times 2 over 5 of x plus 5 minus 3 over x squared minus 1. This is equal to 4 over x minus 1 times 5 of x plus 1, x minus 1. All right, so here, remember, since this is a term, so it'll be 2 times, so here it's 2. The 5 and the x plus 1 disappear for this one, right? And so I'm just left with x minus 1 for this term. For this term, it would be minus. Here it's the x. Let's go ahead and erase this. My marks. So here it would be minus 3. And then for this one, we get rid of the x plus 1, the x minus 1. And so I'm only left with 5. And then here, the x minus 1 cancels, so I'm left with 4 times 5 times x plus 1. Okay. Let's simplify this. So I get 2x minus 2 minus 15 equals 20x plus 20. Okay, and so once again, when we do this, we get down to a normal equation. And in fact, this one's linear. So if I move the x over, I'll get minus, let me give myself a little room. So let's move the 2x this way and the minus 20 this way. So I'm left with 18x. So if I move the minus 2x from both sides, I'll have 18x equals, so I have minus 17 minus a 20 will give me minus 37. And so we have x equals minus 37/18. We'll skip the checking step just because of time, but this one checks out. Okay. All right. All right, for this next one here. This next one here, let's see how I can do this properly. Yeah, so let me kind of tell you what. So x plus 8. So x cubed plus 8 we know factors into something. It factors into x plus 2. And then it'll be x squared minus 2x plus 4. Sadly to say, I don't think you've been ever taught how to factor the cubes. And I'm not expecting you to factor the cubes by your own knowledge, right? So I'm just going to give this one to you. This factors into this, right? But notice that this factor is this here, and this factor is this here. And so that's our least common multiple. So here, our least common multiple is x plus 2, x squared minus 2x plus 4. All right, so we're going to multiply that by both sides. So we have x plus 2, x squared minus 2x plus 4 times 8 over x squared minus 2x plus 4 equals x over x plus 2 plus 24 over x cubed plus 8 times x plus 2 x squared minus 2x plus 4. All right, and then when we multiply, this cancels this term, so it'll just be 8 times x plus 2. This cancels this term, so I'm left with just x times x squared minus 2x plus 4. So this one will cancel this one for this term. And then for this term, this factored into that, so it cancels everything. So this is just plus 24. Okay. So let's clean this up. So here I'll have 8x plus 16 equals x cubed minus 2x squared plus 4x plus 24. And then if we move everything to one side, oh, sorry, this is x cubed. Make it look like an x cubed. Hey, not so rough, you two. Come here. Come on. Come here. There you go. Anyways, and so here we'll have, so here we move everything to one side, so is to be 0 equals x cubed minus 24 minus 24 or 2x squared, sorry. And then I minus this out, so 8x minus 4x would be minus 4x. And then 16x minus 24 is plus 16. Okay, I need more room. Yeah, let's just go up here, I guess. And maybe not that far. I lied. I'm a liar. Just go here. This should be enough room. I'll do my check step here. So I have 0 equals to x cubed minus 2x squared minus 4x plus 16. Do you guys know how to factor this? Yes, no, maybe? Give it a try real quick. Give it a try. You guys know how to factor that? I'll give you a hint. You kind of should. Let's have you at least do one step of this big problem. Yeah, I took away your friend because you're eating it. You can't eat your sister during the show. I gotta do math. You're gonna make me a laughing stock of YouTubers. Everyone says I have dogs that don't behave. Oh, you're right. Hold on. This isn't 16. It's 8. Thank you. Yeah, you can't factor that. Now you can. Now you should know how to factor that. So how do I factor 8x cubed minus 2x squared minus 4x plus 8? Hey. Knock it off, you two. I'll give you a hint. By grouping, if you group this, it works. Can anyone factor this? Maybe. I know, it's Monday morning. No one wants to respond. Everyone's just like fall asleep and just copy notes and not care. I want you to do just a tiny bit of this. All right, at least do me a favor. Respond in chat if you're lost how to factor it. Oh, yeah, someone factored and finished it. Oh, you're still working on it. You guys are going all the way. I just wanted you to factor. Someone went all the way and solved it. You guys are doing great. Okay, you're working at it. All right, I'll keep going. I just had like nothing in chat and I stare at nobody, right? I was like, it's easier to know if you're working in class because I can just see pencils moving or people watching, Netflix on their phones. I remember one time I was teaching 126, not this class, and there was just a kid with like some Beats soundproof headphones watching Netflix, right? Just like the entire time of class because attendance was required. And he was so loud one day we could just like all hear it. And I like tapped him on the shoulders, like, and he's like, what? Can I help you? I was like, yeah, could you turn it at least down if you're not going to pay attention so you're not disrupting the other students? Yeah. So there's like, why did you come? I don't know. I get it. Math's not the best. All right. Yes. So that's correct. So we have, so here we factor out the x squared and we're left with x minus 2, right? Here we factor out a minus 4 and we're left with x minus 2 equal to 0. So I factor that, I get x squared minus 4, x minus 2. And then I can factor this again. I get x, since this is difference of squares, so there's x minus 2, x plus 2, x minus 2. And so my solutions here are x equal to 2 and minus 2. What, dog? I'm teaching class. Here. And so here we have x equals plus 2 and minus 2, right? But notice here what happens if I plug in minus 2, right? If I plug in minus 2 right here, I'm going to go up right here. Hi, doggo. this ends up being a 0, right? And so I get minus 2 over 0. That can't happen. And so this isn't a solution, right? It's not in this domain. And so this problem was designed to show you that the 2 works out. If you put through the 2, you'll get an answer. It works fine. So what happens here is why you need to check is because sometimes when we clear out the fractions, we can produce things which are not in the domain. Notice we didn't find the domain here. We could have, but it's just easier just to check your solutions at the end. And besides, it's easier that way. What's up, Squeaks? And you go. All right. So we have. Can the dogs teach us one day as a lesson? I should, right? Dog, you're fine. I gotta teach the math. I could just use like Snapchat and just turn into a dog and just teach from that. Okay, so that's all the radical stuff. All right, so we have another 25 minutes before the end of today. Yeah, because Monday is the one that technically goes to 11:15, right? So let's go ahead and finish the lecture notes. I know I feel bad, right? I feel bad because at the end of this, I kind of want to say we're done. Let's go, right? Because I filled your brains, right? I filled your brains at this point. But the radical ones are not as bad. You just have to be more careful. So let me explain that and go why. I'll show you why. So let's go ahead and finish these notes for the day. And that way. What, Squeakums? Do you need pee or something? Oh, let me get them started and then I'll go take you out. All right, so for radical equations, these are radical. Ow! My ankle, dog. Okay, we're going to take a 2-minute break. I'm going to put the dogs out because I think they need a pee. 2 seconds. Come on, dogs. Come on, all the way out. All the way out. All right, I'm back. Usually when they're nipping at my heels and they're whining at me, that means they need to go to the restroom. But luckily the dogs are experienced enough they can go out back and wander out back without getting enough trouble. I'm not worried about. So let's do this. So we're going to solve radical equations. So how to solve these is you're going to move the radical or the square root to one side and get everything else on the other side. We're going to exponentiate both sides, so we're just going to square both sides. In this case, we're going to solve for all possible solutions, and then we check all these solutions. And note, this is not an optional since this might produce invalid answers as well. The reason why this produces invalid answers, and I wanted to kind of explain this a little more in detail, is, let me show you with an example, right? Notice that -2 does not equal 2, right? But if I had -2 and I squared it, that does equal 2 squared. And so what happens is we can have serious sign problems, right? And we can do things which become invalid, or when we plug it back in, it doesn't work. And there's just a whole host of things that can go wrong. And so, I mean, A equal B implies, and here's the more mathematical explanation. A equal B implies that AN equals to BN, right? That's okay. But the reverse is not true. AN equal to BN does not imply A equal to B. Case in point, 2 and -2 raised to the second power, right? And so you have to be careful because we can square both sides, but it may produce incorrect results. And so it's probably the first time in math where you're doing something that's not guaranteed to be safe. We go back to example 7. Oh, why we're exponentiating it? Yeah, it's because here, so we're going to do this here, right? And so I'm now exponentiating square roots, right? And the same problem can occur. And I'll show you in a couple of these what can happen. So this one's already, I have the radical on one side, everything else on the other. So the first thing I'm going to do is just square both sides, right? So I'm just going to take both sides. Hold on. I want to get rid of my marks. Actually, go back. Where's my redo button? Why is my redo button not working? Wait. Oh, this is my redo button. La, 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 la. Yep, it's broken. Fine, be that way. All right, so we're going to square both sides. Okay, so we square both sides. So square root squared just means it's 1 minus 2x, right? That's what it means to square root. Here we'll have 3 squared, which is equal to 9. So go ahead and move the 1 over. So I have minus 2x is equal to 8. And then I have x is equal to, divided by the negative 2, minus 4. Okay. And then here we need to check it. So we just check this. So the square root of 1 minus 2 times minus 4, is that equal to 3? Well, this is negative 8 minus, so that'd be positive 8. So 1 plus 8 is 9. Square root of 9 is 3. Yes, we're good to go. Okay. So this one works. We can do the same thing with cubic roots. With cubic roots, we may not run into this problem as much because cubic roots allow negatives in this. And so what am I going to first thing I'm going to do with this side? I'm going to actually cube both sides, right? I'm going to cube both sides. So the cubic root cubed is just 5x plus 5x minus 2. Negative 3 cubed would be negative 3 times negative 3, which is positive 9, times negative 3, which is minus 27. Okay? And then from here, we just solve it. So here we're just going to solve it. And so when we solve this out, we'll just move the minus 2. We'll add 2 to both sides. So I'll have 5x is equal to minus 25, or x equals to minus 5. And so let's test that real quick. So the cubic root of 5 times minus 5 minus 2, is that equal to minus 3? Well, 5 times minus 5 is negative 25. Minus 2 is negative 27. The cubic root of 27 is negative 3, right? And so this one checks out and it's good, right? So our check stuff is good. Okay. So if it's a square root, we square both sides. If it's a cubic root, we cube both sides. Okay. All right, we only have 3 more to go. And we have, I don't know, 20 minutes. So yeah, loads of time. We don't have to use the whole time. I'm pretty sure I've kind of filled the bank of some of you guys's. So let me have you try this one on your own. So give this one a try on your own. Here you do need to move stuff over. So let me do that stuff with you. So you'll have square root of x plus 1. We need to get everything on one side, so it'll be 1. And then I move this over. And so this becomes 6. All right, from here, go ahead and solve it. So give it a try and see what answers you get, and let me know. Do you want to? Yeah, solve the whole thing. Sorry, let me be very clear. The other one, I was just wanting you to factor. I mean, if you got to the whole thing, I was super excited, right? Don't get me wrong, I was excited you finished it. 40? No. You're in the ballpark for sure, right? Because I want 2 times something plus 1 to be this and I take the square root equals 6. So if I square both sides, I get 2x plus 1. Well, I'll let you do it. I'll let you guys do it. I feel like I did something wrong. That's okay. Go ahead and give me whatever answers you get, no matter how wrong they are. If you're doing something, it just makes me happy, right? Because you're trying. And trying is, like I said, I want this class, I want you to be able to say mistakes and not feel guilty or bad about them, right? I got a fraction. Yes, it is that fraction though, right? I'm stuck. So, same. Seems wrong. Oh, really? Yeah, it is that fraction. Let me explain why. So let's go through it, right? And so here we square both sides. So I'm squaring both sides. Oops. My pen's not writing super well. I'm getting lag. It's time to restart the computer. So I square some both sides. So I'm going to get 2x plus 1 is equal to 36. And notice that's what I'm trying to do in my head, because I want to find out 2x plus 1, if I take the square root, what is equal 6? Or it has to equal 6. So that 2x plus 1 better equal 36, right? So I move the 1 over. So I have 2x equals 35. And I have x equals 35. Oh, come on. Please work. I'm going to have to charge my pen too, I think. And this. And now I have to check it, right? So here's the check step. And the check step should just instantly produce that this is the correct answer. I have 2 times 35 over 2 plus 1. Does that equal, or minus 3 equals 3, right? Might as well check it all the way at the beginning. Here, 2 divided by 2 just equals 35. 35 plus 1 is 36. 36, square root of 36 is 3, or 6. 6 minus 3 is 3. So it works out. Fractions in this problem like this always makes me feel like I'm getting them wrong. Yes, I'm pretty sure your book homework will try to break you of that. Because if it randomly generates numbers, it's going to be fractions. Sad but true. It's like, great. We'll go over the homework. We might do that for our extra notes, is just do homework problems on Thursday. That way we just can work through more of these. I don't think there's any. We did the just-in-time notes for this last week to prepare you for this. Just how to work with some of these radicals. All right, so let's do this. So let's do this together. So I want everything on one side. So I'm going to have x plus 4 equals x plus 2. Nope. Nope. X minus 2. I almost did it again. Oh, boy. All right, so x minus 2. Then we're going to square both sides. So now I have everything on one side. So I move this over because that's my first step. Remember, if we had the little steps, this would be step 1, move the radical over. Step 2, exponentiate both sides. Step 3, solve what we have. Step 4, check it. So step 1, we move the 2 over. Step 2, we're going to square it. So this gives me x plus 4, and then x minus 2 squared. Well, that's, x squared minus 4x plus 4, right? Because we have to FOIL. Do not give me x squared minus plus 4. That's incorrect. Please FOIL every time you see a binomial. I mean, it's an easy thing to do, and sometimes I do it because your brain just says, oh, just go for it, right? And it's like, no, slow down a second, make sure you're doing what's right. Move everything over, and so I'm going to get equal to x squared minus 5x plus 0. And so this is 0 equals x plus x minus 5. And so here I have x equal to 0 and x equal to 5 are my two solutions. So I'm going to check them separately. So let's check them. All right, so let's check x equals 5. So here I have x equals 5. So I have the square root of 5 plus 5 plus 4. Oops, let's go ahead and get rid of this. Plus 2, does that equal 5? So 5 plus 4 is 9. Square root of 9 is 3. 3 plus 2 is 5. So yep, this checks out. So let's check x equals 0. Here I'll have 0 plus 4 plus 2 equals to 0. So I have 2 plus 2. So this is 4 equals to 0. This doesn't work. And so we have to throw away this solution. So my only solution, x equals 5, is the only solution. So what happened? Well, when we squared this, we produced a possible solution which isn't true. And then when we did more manipulation, it looked mighty different, right? So this only had one true solution, and it was 5. That's why we have to check. We can create invalid things by squaring both sides. Squaring both sides is not a valid thing you're allowed to. It is valid, but it can cause problems. Make sense? So we have to check. So in this case, if you don't check your answers when you type it in, it's not that you did any of the math wrong. It's that one of the answers just might be invalid. It's just one of the pains in the butts of dealing with radical equations. You just have to check your answers. It's not an optional step. The other stuff is like, yeah, it's a nice thing to do. I can check it, and if it checks out to be good, we're good, right? And I can go on with life. In this case, not optional. You have to do it. And this is why, right? This is why. So this is not a solution, right? Not a solution. Okay, we did none of the math wrong, but by squaring, we may introduce invalid answers. Okay. And I want to show you this one. So here, in some cases, it's impossible, right? This is impossible to get only the radicals on one side and everything else on the other side, because what do we have here? We have a radical plus a radical. So yeah, technically all the radicals are on one side and everything's on the other. In this case, you end up just squaring. You end up squaring both sides, and you end up having to do it twice. Let me just walk you through this one, and then if we have more of these on the homework, I'll walk you through them again. So in this case, the easiest way, just because I've done this before, is you move one of them over, right? You have 5 minus x minus. So I'm minusing this from both sides, and in this case, I'm going to square it from here. Okay, and so this is, since it's impossible, so you want to say if possible, right? So in this case, it's impossible to have just a radical. Here we have a radical and a radical, so it's not one radical. You could just square this side and square this side and go, but you end up with a square root times a square root, and that ends up being a bigger mess. So in this case, move one of them over, square both sides. So this is just x plus 3 equals, if I square this, I get 5 squared, which is 25. I get minus 5 times this minus 5 times this will be minus 10, x minus 2. And then this times this would be positive x plus 2, right? Because I'll have a square root times the square root. So it'll be the square root squared. So it gets this. Okay, so once again, x minus 3, the square root of x minus 3 squared is this. I'm going to rewrite this. Instead of squared here, instead of squaring both sides, I'm going to write this as 5 minus x minus 2. That way it makes it a little easier to see what I'm doing here. So 5 times 5 gives me 25. 5 times negative x minus negative square root of x minus 2 is minus 5x minus square root. And then here would be 5 times minus x minus square root 2. So these two together give me a total of 10 minus x minus square root 2. And then I have negative x square root of 2 times negative square root of x minus 2. That squared is just x minus 2, or x. I wrote plus 2, and it should be minus, didn't I? Good. Oh, I wrote I wrote minus here when it should have been plus. There's my problem. Whoop. Notice here it's a plus, so keep this the same. I was like, something went wrong. Okay. Make sure you copy the equation from here to here correctly. Oh boy. And so here, this is also a plus, right? So minus 5 square root of x plus 2 minus 5 square root of x plus 2 becomes minus 10 square root of x plus 2 in this. Once I've done this, I only have one radical. Then I can go back and solve it the way I taught you how to solve it. Move everything to one side and pull everything out. So here, I'm going to start stuffing everything to one side. So I'll add minus an x, a minus x. So minus x on both sides. The x's just end canceling, right? They just end up canceling. I move over the 2. So it'd be minus, oops. I wrote plus 3, didn't I? I didn't copy any of this correctly. X minus 3 squared is x minus, square root of x minus 3 squared is x minus 3. If I have an x on both sides, I can cancel the x on both sides. So this would be minus 2, so that makes it negative 5, and this becomes minus 25, so this would be minus 30 equals minus 10 square root of x plus 2. Okay. Then I divide out the negative 10, so this becomes minus 3 square root of x plus 2. And then you square it again. So this gives me 9 equals x plus 2, or x is equal to 7. I only have one answer here, so I'm going to check it. So here, I'm checking x equals 7. So here I have the square root of 7 minus 3 plus the square root of 7 plus 2. Does that equal 5? Well, the square root of 7 minus 3, so this is the square root of 4, so that's 2, plus 7 plus 2 is 9, square root of that is 3. Does that equal 5? Yeah, so this works out. All right, so once again, let me explain what I did in general terms so you know what to do. If you see 2 radicals on one side and they're terms, so it's multiple, there's a plus sign in between them, move one radical to another side, square both sides. You'll get rid of one of your radicals and the other one will still remain when you square both sides. You'll still get this middle term here. We'll still give you a radical. But then you only have one radical to deal with instead of the 2. Then you can just move everything to one side, square again, and then you should be left with an equation you know how to solve. Solve the equation, check your answer. Okay? All right. Well, that's the end of the lecture. So put a little happy star. That